So Lana, welcome to lesson number 2 on formula and variations. So in a previous lesson, we discussed about a formula and making variables the subject of the formula. So in this case, I want us to understand what is meant by variations and also illustrate on the different types of variations used in mathematics. So in this case, in the first place, I define variation as a relationship between variables of different values in a formula. So an example, we have this formula that talk about the equation of a line, which is given by y is equals to mx plus c. So in such a formula, you realize a change in the value of 1 alters the change of other variables present in that formula. So we're going to see that you have variables, if they increase, they cause an increase on other variables. We're also going to see other variables, when they increase, they result to a decrease in other variables. So in mathematics, there are 4 types of variations. So let me have the types of variations. So in this case, 1, we have what you call direct variation. As the word suggests. We also have what you call the inverse variation. We have what you call joint variation. And lastly, we have what you call partial variation. So in each case, I'm going to illustrate on what we're supposed to put into consideration as we try to work out a few problems here and there. So in the first place, I begin with direct variation. So in direct variation, a direct variation is where you have a change in a variation that causes a positive or direct impact on a variable. So I'll simply say this. And a direct variation, a change in a variable causes a positive change on other variables. So what do I mean by this? I.e., by this I mean an increase in one variable results to an increase in the other. For example, i.e., you can be told P varies directly as maybe T in this case. So in this case, this simply means an increase in P will cause an increase in T, and a decrease in P will cause a decrease in T. So in this case, we have what we call direct variation. So in this case, if you want to put this one mathematically, simply say P is directly proportional or directly in variation to T. This is called the sign of proportionality. So in this case, we can have it this way. P, I introduce a constant, P, K, T. So from this formula now, we can get the value of what? The value of a constant. Because of course, in every formula, we have values that totally do not change. We refer to them as constant. So in this case, I'll be having P, to remain with K on this side, I divide by T. So in this case, I'll have P over T is equals to the value of the constant. So hope you've noted that. So in this case, I'll also get another example and see what happens. So students, let's consider the question popping on your screen. Consider that question on direct variation. And I'll help you read the question. The question reads, a quantity C varies directly as quantity D. You are told if C is equals to 22, when D is equals to 7 centimeters, find C when D is equals to 28 centimeters. I read the question again. A quantity C varies directly as quantity D. You're told if C is equals to 22 when D is equals to 7, find C when D is equals to 28 centimeters. So let's translate the question. You are told a quantity C varies directly as D. So in the first place, we have to find a constant in this expression. So we need to do away with this sign of proportionality by introducing a constant. And in this case, we need to do away with the constant. So I divide by, okay, with D on this side, by D, or by D. So in this case, I get the value of the constant will be given by what we call C over D. And from the formula we are told that if C is equals to 22, we are told C is equals to 22 when D is equals to 7. So you have to get now the actual value of the constant. So K is equals to 22 over 7. K is equals to 22 over 7. And with this we get the actual value of K is equals to, so in this case we get 3.142 as the value of the constant. On the other part of the question, you're told to find C when D is equals to 28. So we get back to our formula up there, whereby we have the value of K. So in this case, our formula turns out to be 22 over 7 is equals to C over D. Sawa? And in this case, we have 22 over 7 is equals to C over, we have the value of C of D as 28, as 28. So how do we get D in this case? Okay, to remain with C on one side, we multiply both sides by 28. So cancels. So in this case, we're going to get C is equals to, by 7 1, by 7 4. C is equals to 88. And that's how we apply the formula we get from translating the proportionality. So students, let's embark to our example number 2 that is popping on your screen. And in this case, you're told, given that Y varies directly as the square of X, and that X is equals to 2 when Y equals to 3. You are told to find Y when X is equals to 12. I read the question again for you. The question reads like this. Given that Y varies directly as the square of X, and that X is equals to 2 when Y is equals to 3. You are told find Y when X is equals to 12. In the first place, we first translate the question, whereby we are told that Y varies directly as the square of X. Y varies directly as the square of X. So in this context here, we introduce a constant, and the constant is going to do away with this sign of proportionality. So in this case, we're going to have Y is equals to Kx squared. And in this case, K stands for the constant. And I said in every formula, we have values that remain constant at all times. So in this case, let me have this. So I want to get the value of the constant. So in this case, I divide by x squared by x squared. So K is equals to Y over X squared. That is the formula you are having. But you can get the exact value of K, of this particular constant, to use during the application of our formula. So in this K, remember we are told that Y is equals, we are told that Y is equals to 3. So 3 over X squared, we are told that X is equals to 2. So 2 squared is equals to 4, which means the value of K, that constant, is 3 over 4. So in the second part of the question, we are told to find, Y when X is equals to 12. So in this case, 3 over 4 is equals to Y over X squared. And we want to get the value of y when x is equals to 12. So we're going to have 3 over 4 is equals to y over 144, because we are told x is 12. So the square of 12 is equals to 144. So in this context now, student, in this context, I'm going to have the value of y as I multiply by 144 there, by 144 on both sides. So y is equals to 3 over 4 multiplied by 144. So in this context, we're going to get our answer as So in this case, by 4 there, you get 36. So y is given by 36 times 3, which is equals to 108. So I get we are together and we are conversant with how we go about the direct variation. So in this case, I want us to have a look at now the inverse variation. Inverse variation. So inverse variation in this case, when it comes to inverse in proportionality, in this case, a positive impact on one variable causes a negative impact on the other. So what do I mean by this? By this I mean, if one value increases, it results to a decrease in the other value, and hence the term inverse proportionality, inverse variation. So for example, you could be told that a variable q varies inversely as a variable p, for example. So in this case, this means q, we have to include that sign of proportionality. This q varies inversely as p. We put an inverse of a number is 1 over that number, or can be written as p raised to -1. Right? So I've said this. In inverse proportionality, an increase in one value results to a decrease in the other. I've given an example and I've said you could be told that a variable q varies inversely as p. So in this case, mathematical expression, so we have q varying inversely as p. So in inverse variation, if you're told a number varies inversely as the other number, we put that number that varies inversely as 1 over that particular number, or that number raised to -1. Now, so in this case, we can have a question. Allow me to do an example here, so that now for further understanding. So let me have example 1 of inverse variation. For example, consider that question appearing on your screen. Consider the question appearing on your screen. And in this case, the question reads as this. You're told, it is given that P varies inversely as Q. And when Q is equals to 3, P is equals to 1 over 6. And then the examiner expects you to find P when Q is equals to 9. I repeat the question again together. We are told it is given that P varies inversely as Q, and that when Q is equals to 3, P is equals to 1 over 6. And then you are told to find P when Q is equals to 9. So I simply say this. We are told that P varies inversely as Q. So we have 1 over Q. So in this context, I said we introduce a constant to get rid of this sign of proportionality. So in this case, we're going to have P is equals to K multiplied by 1 over Q, which is the same as P is equals to K over Q. So, and we need to get now the value of this constant. I said a constant is a value that never changes in a formula. So in this case, to get to remain with K on this side, I have to multiply with the reciprocal of Q. So multiply by Q over 1, multiply by Q over 1 on both sides. So in this case, I'm going to get that K for constant is equals to, K for constant is equals to Q multiplied by P, which is the same as K is equals to QP. In the question we are told, that when Q is equals to 3, so K is equals to, we are told Q is equals to 3 when P is equals to 1 over 6. So multiplied by 1 over 6 to stand in for P. So the value of the constant is equals to, the value of the constant is equals to, by 3 1, by 3 2, is equals to 1 over 2 or 0.5, whichever way you can choose either to use decimals or fractions, but in this case I would advise you to always use fractions, or in any case nothing can go wrong. You're taught to find P, you're finding the value of P when Q is equals to 9. When Q is equals to 9, we're supposed to find Q. How do we go about that? So our formula formed, the expression illustrating the context given above should be 1 over 2 is equals to QP. So that's the formula, that's the expression connecting those variables up there. So in this case, I'll have 1 over 2 is equals to Q. We are told Q is equals to 9, but we are lacking the value of P. So how do we go about that? In order for us to get the value of P, so we divide by 9 on this side and by 9 on the other side. So in this case, we're going to find that P is equals to 1 over 2 multiplied by 1 over 9. So P is equals to 1 over 18. P is equals to 1 over 18. And that's how we go about that. So let's consider example number 2 for further understanding. So example number 2, consider the question appearing on your screen. Example number 2, consider the question appearing on your screen. And the question reads, pressure denoted as P varies inversely as the area denoted as A. It acts upon, full stop. Find the equation connecting P and A if P is equals to 60 when A is equals to 40. I repeat again and say, pressure denoted as P varies inversely as the area A it acts on, full stop. You're told to find the equation connecting P and A if P is equals to 60 when A is equals to 4. First of all, I said we must translate the question. In this case, the question we translate as this. We are told that P, which stands for pressure, you are told it is inversely proportional or varies inversely as area. So I said under inverse, it's going to be 1 over that particular variable. You are told that varies inversely. So in this case now, we're going to introduce a constant to get rid of this sign of proportionality. So P is equals to, I introduce a constant multiplied by 1 over A. So at the end of the day, we have an equation as P is equals to K over A. But in this context, we want to get the exact value of the constant because we are given the value for P and the value for A. So how do we go about it? So in this case, I want to get K. I multiply by the reciprocal of A on both sides by the reciprocal of A. So this cancels out with this and this multiplied by this. So we get constant. The value of the constant will be area multiplied by pressure. From the relationship we are told they incur in that particular context. So the exact value of the constant will be K is equals to, we are told that in this case A, or for area, is equals to 4 multiplied by pressure, that we are told pressure is equals to 60. So the value of the constant will be K is equals to 240. But the question tells you you're supposed to find an equation connecting P and A. Simple. So in this case, we said that K is equals to AP. So the equation that connects the two will be, So the equation connecting the two will be, we said that P is equals to the constant over area. So in this case, the equation will be P is equals to 240 for constant over area. That is the equation that connects P to A or A to P respectively. And that marks the end of the lesson on inverse variation. Remember to subscribe, share, and comment. And in case of any further clarification needed, you just leave a comment down below. Be blessed. Let's continue learning.